Now for this problem, you need to determine the force F needed to hold the 4 kg lamp in the positions shown. To do so, we first draw the free body diagram of the figure. Here, we have AX and AY. And the lamp shown here has a weight of 4 kilograms. To get the weight, we multiply it with the gravitational acceleration of 9.81. That is equal to 39.24 newtons. Then we have dx and dy. Now to solve this, first we consider joint B. At point B, we have a 39.24 Newton force and a tension AB that is acting 60 degrees and tension BC that is acting at 30 degrees. Now to solve for these two unknown forces, we can do summation forces vertical and horizontal. So by taking summation force X horizontal, we get negative TAB cosine of 60 degrees plus TBC cosine 30 degrees equal to 0. That serves as our first equation. For second equation, we take summation force vertical Fy equal to 0. This becomes TAB sine of 60 degrees minus TBC of sine 30 degrees minus 39.24 equal to 0. That serves as our second equation. Now we have two simultaneous equations with two unknowns. Let us first arrange this equation. For equation 1, we have TAB times negative cos 60 degrees plus TBC cos of 30 degrees equal to 0. And then for our second equation, we have TAB times sine of 60 degrees plus TBC of negative sine 30 degrees equal to 39.24. The reason why I arranged this the way I wrote is because you can input this directly in our calculator to solve two equations to unknowns by going to mode 5.1. Now for our first variable A that represents tension AB, and for the second variable B that represents our tension BC, and for the last variable C that represents our constant on the right side of the equation. Now tension AB has a constant coefficient of negative cosine 60 degrees, and tension BC has cosine 30 degrees with a constant of 0. From the second equation, TAB has sine 60 degrees and TBC has a constant of negative sine 30 degrees equal to 39.24. Here we can solve TAB that's equal to 67.97 and TBC is equal to 39.24 in newtons. Okay, now we have the value for the tension AB and BC. We can now proceed solving tension C, CD, and F by considering joint C. So at joint C, we have a missing force F that we want to solve tension BC with a value of 39.24 newtons. That is acting with a missing angle. It is an angle of 30 degrees. By the alternate interior angle theorem, this angle should be equal to 30 degrees. And we have a unknown force, tension CD, acting at 30 degrees upward. To solve for force F, we need to solve first for tension CD by summing up forces horizontal, that is equal to 0. So negative 39.24 cosine 30 degree plus tension CD cosine of 30 degree is equal to 0. Dividing both sides by cosine 30 degree, we get 39.24 plus TCD is equal to 0. Therefore, TCD is just basically equal to tension BC. That is 39.24. Actually, you don't really need to solve this because you can notice this by symmetry that the horizontal force must be equal. Now to solve for the value F, we can do summation force vertical. So 39.24 sine of 30 degree plus another 39.24 sine of 30 degree minus F is equal to 0. So F is equal to twice of 39.24 sine 30 degrees. We get 39.24 newtons, and that is our final answer.